I think a 3 by 3 for the record, okay? Can you do 4 by 4, 5 by, yeah. But those we would do, of course, in our calculator. So this is what we're working on. Okay, so first, when we do these, they're gonna talk a lot about the identity matrix, which you kind of know and have seen. Identity matrix, of course. So if you read through all of this, okay, it's the same as you multiply by 1. It's the same thing in matrix multiplication. So identity matrix, notice the little subscript here too. That's just for the 2 by 2. All the identity is, which we've seen, is your diagonal 1s, 0s above and below. Same thing, diagonal 1s, 0s above and below. Diagonal 1s, 0s above and below. And obviously the subscripts 2, 3, 4 just depends on the size. We're going to be working on 2 by 2s today and 3 by 3s today. We will not make you do a 4 by 4 by hand. That would just be mean. That would just be mean. So if you multiply a matrix by its identity, you get the same thing. Just like if you do 5 times 1, it's 5. Okay, it doesn't change the value. So that's just what this is showing you here. Notice I just copied the work down because I'm like, this is not worth making you write in. Let's just look at it. So following shows you if you multiply a course, here they're multiplying your diagonal 1s, you get the exact same matrix. Same thing here. Your diagonal 1s, you get the exact same matrix. Now you might be questioning, like, wait a minute, this guy up here is not square. This 3, -1, 5, 2, 6, 7, which it doesn't have to be on matrix multiplication. But just remember, think about your quiz tomorrow, the size of this one is a 2 by 3. So this would have to be the 2 by 2. Because remember, you need those inside dimensions to match. So just for the reason. Now here's what we're really going to be doing today. This is the key little note. So if A times B equals the identity, diagonal 1, 0s above and below, B times A gives you the identity. You also know that they are inverses of each other. So one of the things we're going to do, they're going to give you 2 matrices. We're going to prove or verify that they're inverses of each other. Well, all that is a little multiplication, and we should get that diagonal 1s with the 0. So we just have to, of course, do the work. Verify B is the inverse of A. Eventually, we'll actually find the inverse. So basically, we have to do A times B and B times A. That's kind of the yuck thing. You do have to do both directions of multiplication and verify that both answers are the diagonal 1s. And, so I love this lesson before the quiz, gives us a chance to review how to multiply matrices together, okay? Obviously, 2 by 2s all around, we can do it. Now, multiplication, rows, columns. So rows of A. So I'm going to start with that, 2, 1, 5, 3. And then remember, it's the columns of the second matrix. So 3, -5, -1, 2. And now, of course, we just start multiplying to our little heart's desire. We make sure we do the full grid, add up anything. 3 times 2, 1 times -5. I'll total them in a minute. 5 times 3, 3 times -15. 2 times -1, 1 times 2, 5 times -1, 3 times 2. All right, let's total. So it looks like 1, 0, 0, 1. So we did get the identity matrix, which we should if they're inverses. If they're not, you would not get that. Now, it has to work both directions. So, yeah, I know it's yuck. We do have to do it the opposite way and do the work. Now, let me erase all this writing I have up here on A and B because it's going to switch. I need rows of B, columns of A. Now, do we have to rewrite the matrices and get all crazy? No. We just recognize rows of B. So 3, -1, -5, 2. And then I need columns up and down of A. 2, 5, 1, 3. And again, this really simple, but good, we can review how to multiply because obviously that's going to be on your quiz tomorrow. 3 times 2, -1 times 5. -5 times 2, 2 times 5. 3 times 1, -1 times 3. -5 times 1, 2 times 3. Total it up, really shocking. We have our identity matrix, therefore they are inverses. Okay, so good review on multiplying, because there is some multiplying on your quiz tomorrow, by hand, no calculator, not that hard. Any questions on multiplying? Okay, let's show you then how to find the inverse. Now, obviously, 2 methods. We're going to look at one. This honestly is a shortcut on a 2x2. It's the 3x3 that's going to be time consuming and kind of, well, stink, okay? So this is a shortcut on how to do a 2x2. I will show you the long way, although I doubt you're going to use it, but I'll just show it to you or talk about it briefly too. So to do your inverse, remember, this little symbol, this 2 to the -1, means inverse. That, it always pains me to say it. This key on your calculator, that's not x to the -1, that's the inverse key. That's what we're going to use to find inverse of our matrices on the calculator when we get to it, just for the record. All right, 2x2, super easy. So notice the first calculation is this. So you're going to do a times d, so you're basically multiplying on the diagonals, minus b times c. And that, of course, will be a value, some sort of number you will get. Notice if it's 0, you can't do it. 1 over 0 is undefined. We can't multiply by undefined. It's just weird. Won't be able to do it. And then, of course, okay, check the order here. Notice your D and A, that diagonal, the numbers just switch spots. So if you had 2, 5, you make it 5, 2. And notice these guys have negatives. So it looks crazy with all the letters, but I promise once we start doing the calculations, the actual math to it, it will be simple. So first thing I'm going to do is this part, the AD minus BC. Well, let's flip the page. So I'm going to do AD, 4 times 3, and then I'm going to do the B times C. So first calculation I'm going to make is that. 12 minus 10, I got 2. So when I'm doing my inverse, it's going to be 1 over the 2 times, let me erase all that blue up there so I can kind of write on it. So here's what you have to remember. It's the setup. The 4 and 3, they just switch spots. That's all that happens. 3 is going to be top left, 4 bottom right. And then the other 2 numbers, the 5 and 2, they stay in the same location. You have to switch the signs on them. So 5 is going to be a negative, 2 a negative. And of course, if they were negatives, I'd switch it to positives, clearly. Then all I have to do to get my inverse is distribute the half through to everything. Yeah, we're going to have some fractions. It's not the end of the world. So I'm just half times 3, 1 1/2, 3 halves, however you want to write it. Half times -2. Half times -5, half times 4. And there is your inverse. So it's easy. You just have to remember the calculation. So A and D, they just switch spots. That's easy. The other ones stay, but you change the sign. And they just multiply it through. Clearly, it's the 3x3 that's going to be time consuming. Are you ready for it? I don't feel any enthusiasm, class. Okay, because there's not on this. Here's where it's going to get Gauss-Jordan-ish. So first you have to be a square matrix. So if they ask you, thank you, if they ask you to do the inverse and the matrix is a square, you just write not possible. You can't even do it. Okay, make your life easy. Then you're going to put on, let's switch here, the identity matrix. So the 1s, the diagonal 1s and the 0s, and you attach that to the right side. So basically what you're going to do is kind of this little, I'm going to have my original matrix. I just like the little dashed line to separate them. And then behind it on the right side, I put the diagonal ones with the 0s. And again, we're only going to make you go as far as 3 by 3s by hand, not any bigger. Here's where it gets fun, or Gauss, Jordan-ish. We're going to row reduce. So that's all the multiply by this, add to this row. We're going to row reduce it down to the identity. So basically what happens is that you want the diagonal ones and the zeros in the front half. Whatever numbers are at the back as your answer. So it's like they switch locations is what you're after. And I'm sure, sarcasm, everybody's going to do number 3. You're going to check your answer by multiplying out the original with your inverse to make sure you get the diagonal ones. I'm sure we're all going to do that. Probably not. Okay, so here's what we're going to do. Simple enough. You slap the diagonal ones and the zeros at the end. We're going to do our row operations. So we get the front half, the ones and the zeros. Last half's my answer. So here we go. So I don't even bother like rewriting it because space people. I just kind of put a little dash. And I'm going to put my diagonal ones and the zeros. Okay. Now, and this is good review for Gauss-Jordan. In general, so you can kind of space it out, how many matrices does it take us to do Gauss-Jordan? 4. Which in general is what this will take you to, because you work in the same order, a column at a time. So I want the 1, which we've got. I want to make the 3 a 0 and the -1 a 0. So my top row is perfect. So I'm just filling it in. Next, I'm going to change the 3. Easy question, what cancels 3? So we have to do, it's long, this whole crazy top row by -3 and add it to the middle. We have to go all the way across. You just have more calculations to do. -3 times 1, -3 plus 3. -3 times 2, -6 plus 7. Oh, I kind of like that. Still going. -3 times 2, -6 plus 9. Still going. I need longer arms. -3 times 1, -3 plus 0. -3 times 0, 0 plus 1. -3 times 0, 0 plus 0. So just more calculations. Okay, let's get rid of -1. Well, that's easy enough. I would just do what to these 2 rows? Add them together. I'm just going to add them. Piece of cake. 1 plus -1. 2 plus -4. 2 plus -7. Keep going all the way across. 1 plus 0. 0 plus 0. 0 plus 1. Got it. So same process as you work for Gauss-Jordan, which is good review. Column 1, beautiful. Column 2. So we've got the 1, which is a win. We're going to use that to change the 2 and the -3. So my middle row is perfect. So I'm just going to rewrite in the middle row. I'm just going to scroll it up a little bit too here. Okay, doesn't matter if we do the 2 at the top or -2 at the bottom. We have to do them both. I'm going to do the 2 at the top. Get rid of the 2, I need -2. So I'm going to times this whole row, so many numbers, by -2, and we're going to add it to the top. -2 times 0, 0 plus 1. -2 times 1, -2 plus 2. -2 times 3, -6 plus 2. -2 times -3, 6 plus 1. -2 times 1, -2 plus 0. -2 times 0, 0 plus 0. All right, bottom row, here we go. What cancels out a -2? +2. So I'm going to change this, I'm going to cross it off to a 2, and we're going to add and change the bottom row. You take a minute, practicing for our quiz tomorrow, and do the calculations for the bottom row. You're up. The math for you, but let's just see how we did. You should end up with 0, 0, 1, -5, 2, 1. Okay, let's do it. 2 times 0, 0 plus 0. 2 times 1, 2 plus negative 2. 2 times 3, 6 plus negative 5. 2 times that, negative 6 plus 1. 2 times 1, 2 plus 0. 2 times 0, 0 plus 1. Okay, now, last column, people, we're on the home stretch. We clearly have, circle it in this guy, this guy. So one nice thing about, and this is time consuming, I can't try to tell you it's not, it is time consuming. But usually I can do this, I'm going to scroll it up a little bit, in 3 matrices versus 4. Because remember, Gauss stored on starts you with the equations, and you have to write the original matrix. At least you have kind of the original problem, so that kind of saves you a matrix. So I think I can get it done on this next one. I'm just going to scroll it up so I'm not at the bottom. Okay. So our bottom blue number's perfect. We want that 0, 0, 1. So I'm just filling in the bottom. Okay. We've got to change the green 3 and the red negative 4. Who cares what we do first? We got to do them both. I'm going to do the green 3 because I picked up green. So to get rid of 3, we need a negative 3. So start calculating. Negative 3 times 0, 0 plus 0. Negative 3 times 0, 0 plus 1. Negative 3 times 1, negative 3 plus 3. Negative 3 times negative 5, 15 minus 3. Negative 3 times 2, negative 6 plus 1. Negative 3 times 1, negative 3 plus 0. All right, top row. And we're finally going to be done with this. To get rid of a negative 4, we need a 4, so I'm going to change it to 4. We're going to go to the top. 4 times 0, 0 plus 1. 4 times 0, 0 plus 0. 4 times 1, 4 plus negative 4. Now here's where it really counts. 4 times negative 5, negative 20. What's negative 20 plus 7? 4 times 2, 8 minus 2. 4 times 1, 4 plus 0. Okay, whew, almost making my arm hurt. Now, final answer is not just this, okay? But it's, 4-day weekend, we're tired. So here's what I do, work smarter, not harder. The final answer are the numbers on the back half. The back half is your inverse of the matrix. So, can you get dramatic and rewrite it all out? Yeah, I don't think we have that in us. Here's how I cheat it. I just bracket it off and I circle it. So these 9 numbers at the back are the final answer. Just make sure you indicate that. If you want to write it out totally separate, be my guest. But at the very least, bracket it off for a matrix and circle it so I know that it's the back half. Wasn't that fun?
No, it was horrible.
It is horrible. It is. Okay, so just to show you, I'm going to do that last one. You could have done this one the same way, this little 2x2, put your 1, 0, 0, 1 on, and do the row operations. But again, I think this is a lot quicker and less time consuming. But you could do the 2x2s the same way as the last one. I don't think anybody wants to do it that way. Am I right? Okay, let's do another 3x3, shall we? Let's do it. Let's do it. Okay.
Let's just do the next 2.
The calculator ones?
Let's do those.
Because we're going to all rock Gauss stored on tomorrow.
Yeah.
Is what we're saying.
I'm studying it.
Oh boy. Okay. Now remember, in general, you can do this 1 and 3 because you don't have to write out the original equations in a matrix. But it is more time consuming because we have more calculations. Okay, column at a time. Same deal. We got our top left one. Love the top row. Fill it in. And we're going to change out the 2 and then the negative 3. Okay, 2, of course, we need a negative 2. So I'm going to do this guy, need taller shoes, times negative 2 and add it to the middle. You're up. That's what you got. I feel like I should have Jeopardy music playing. Everybody's got this middle one, it looks like, pretty well. Okay, so here we go. So negative 2 times a negative 2, 4, plus that. Got it. Negative 2 times a negative 4, 8, minus 6. Negative 2 times 1, negative 2, plus 0. Negative 2 times 0, 0, plus 1. Times 0, 0, plus 0. How'd our middle row look? Working on the bottom one, I see some of you. So to get rid of negative 3, of course, we need a 3. So I'm going to change it to a 3. And let's multiply and add. 3 times 1, 3, plus that. 3 times this, negative 6, plus 6. Like it? 3 times negative 4, negative 12, plus 15. 3 times 1, 3, plus 0. 3 times 0, 0, plus 0. 3 times 0, 0, plus 1.
Wait, why is it not negative 3?
Why is it again 1?
Why is it not negative 3?
Where did I miss the sign?
Negative 4 times 3, negative
12
Oh,
plus
never mind,
15.
never mind.
No, it's all right. It's early. It's early.
Oh.
It's early. It's early. No worries. Okay, next
Oh.
column. So you've got the 1. Winning, winning. So our middle row, red numbers, beautiful. Clearly, we need to change the top. Green, negative 2. Wait a sec. We're winning. Because what about that blue 0 underneath? Do I need to change the blue 0? No. So that's good. I'm going to go ahead and fill this one in too. Whew, all right, saves me a little bit of work. I like that. So we've got the 0. Let's just get the negative 2 to a 0. Clearly we need a 2. We'll add it into the top. 2 times 0, 0 plus 1. 2 times 1, 2 plus negative 2. 2 times 2, 4 plus negative 4. 2 times negative 2, negative 4 plus 1. 2 times 1 is 2 plus 0. 2 times 0, 0 plus 0. Looking good. Looking good. Okay, working on, we're on the home stretch, believe it or not. The last column, it may not feel like it. Now, a couple of deals with the last column. This 3 needs to be a what? How are we going to get to a 1? Divide by 3, which is going to result in a fraction, which we're not going to freak out about 1/3. Right? Nobody's freaking out that we're going to have 1/3. So I'm just going to divide this whole row by 3 right now. One-third. And again, I rewrote it all nice and pretty. You don't have to. You could have just changed them here if you wanted to. Okay. Let's get rid of the, now, I like it. Let's do the green 2. To get rid of a 2, you need a what? Negative 2. And we're doing these numbers that I divided out into this middle row. Negative 2 times 0, 0 plus 0. Negative 2 times 0, 0 plus 1. Negative 2 times 1, negative 2 plus 2, winning. Negative 2 times 1, negative 2 plus negative 2. Negative 2 times 0, 0 plus 1. Oh boy. What's negative 2 times a third? Negative 2/3 plus 0. That's not that horrendous of a fraction. And do we need to change anything about the top row? No, you've got your 0 right there. Copy it down. Okay, so check the front half. Is the front half the diagonal ones and zeros? Sure it is. So make sure you know, like you tell me that I know that you know that your answer is the back half. So I'm going to bracket that off and circle it. I'm not going to rewrite it. And look at us. We handled 1/3. I'm so proud. So proud. Okay, now to everybody's favorite, the calculator ones. Which, let me put the calculator ones. I've got them out of order, the slides here. Are you already doing the calculator ones? Oh,
I'm just
okay.
saying that probably one of them is not possible.
Am I getting predictable in my old
Yeah,
age?
because you always give us the graphing calculator is not possible, not like the normal like working.
All right, I just have these like separate so I can like pull up the calculator here. All right, start typing it in, of course.
I'm so mad.
Now, remember of course tomorrow, focus here my friends, is no graphing calculator, but this will be on your test when we get to it. So into your matrix menu, I'm going to go to edit. I'm super lame. If it's just a single matrix, I do everything as letter A. That's just how I do it. A is highlighted. I get to swap out the size though to 3 by 3. And start typing in the numbers. You know I love typing on this thing. 0. I hate this thing. 1. Okay, 1, 0, negative 6, negative 2. Okay, let me just double check I don't have a typo. You know I get paranoid on this thing. Perfect. Okay. Do you have yours typed in? Now, I'm going to try not to get on my hatred of Texas Instruments because, of course, the inverse is not in the matrix menu. Why would it be in there to make our lives easy? We wouldn't want that. You have to quit out, of course, once you get it typed in. Now, I'm going to pull up the matrix. So I did mine as letter A, so I'm back into the matrix menu, and I want A on here. And remember, the inverse key, this pains me to say it, is on the left side, and it looks like x to the negative 1. This really means inverse.
Oh,
So when I hit that, it puts the inverse function on. I hit enter. There it is. Write them down. Now, same thing too. Let's say you could have done that this whole time. So let's just say too, if you had a lot of decimals and you want fraction answers, because my answer key might have fraction and you want to check yours, you can hit math, enter, enter on them, and it will kick them all into fractions. Okay, let's do the next one. Let me slide it over here. Start typing, of course. So again, I just do everything as A. Matrix, edit. A is already 3 by 3. So 1, 0.
oh wow, error. Am I surprised?
Wow. Marissa!
Not.
Okay, so I'm just double checking. I've got it typed in. You're going to quit out of it. So you're in a home screen. We want to pull up our matrix, which of course I did mine as A, and hit my inverse key. And like Marissa said, you get this lovely error message.
Oh my god.
I know, I'm getting predictable in my own thing. So just write that, not possible, does not exist, whatever you want to put. Here's the deal, you're really going to love it. So what does that mean when it doesn't exist? Here's where you really would probably hate me. If you did all of this work by hand, let's say it's a by hand one, and I'm just cranking away on my Gauss Jordan steps, I'm trying to get my 1, 0, 0, there's no possible way you can get this diagonal ones and the zeros in the front half. You just can't make the numbers work. You can't make the math happen. That's when you have a do not exist. That doesn't always work on every problem. You can't make the diagonal ones. That's what that really means on the calculator. I